Welcome to Neal on Fire, the podcast where we explore the technology, science, and strategy shaping the future of wildfire resilience. Today, I'm joined by Lieutenant General Larry James, U.S. Air Force retired. Larry has held leadership roles in military space operations, national security, NASA's Jet Propulsion Laboratory, and today serves as strategic advisor to SmartSat, one of Australia's leading space technology organizations. We'll be discussing the role of satellites, Earth observation, AI, space-based technologies, all in support of addressing, of course, wildfires. So, Larry, thank you so much for joining us today. Looking forward to talking to you.
Well, Neil, happy to be here. And obviously, this is a very important topic across both the U.S. and Australia. So I look forward to the discussion.
So, you've had a remarkable career spanning the Air Force, national security space operations, JPL, and now SmartSat. So, how has that background informed the way you think about wildfire resilience and overall Earth observation?
Well, I think number one, as you said, I've been doing this a few years. And I think just seeing the trajectory of capability has been very important. Again, you go back 30 years, we frankly didn't have the tech to do a lot of the things we're talking about doing today. Number one, it's, just the sensors and the capability of sensors today, a spacecraft and the fact that we can do very important missions with very small spacecraft and very miniaturized sensors. And then the cost of launch, frankly, when you talk about space and utilizing space for wildfire detection and wildfire management, all the things that have happened in the last decade with miniaturization, with CubeSats, with SpaceX reducing dramatically the cost to get into space and other organizations doing the same thing. So the whole dynamic has changed in terms of what we can do from space. And I think applying those lessons from the sensor perspective and the satellite perspective, but also now from the data perspective. We can create huge amounts of data and we can now analyze huge amounts of data. We can apply AI, we can apply machine learning, and all those things come together in today's environment to really create opportunities to do much better in wildfire detection and management.
So, having overseen very sophisticated space systems during your military career, I'm wondering where are the parallels when you came into this role at SmartSat? Where did you say, aha, you know what? My background is going to fit perfectly for this because of this experience that I have. What do you think when you look back on that were kind of the key experiences that fit so well with wildfire resilience from a satellite perspective?
I think number one is just understanding the sensor technology through the years. I was the head of intelligence, surveillance, and reconnaissance for the Air Force in the U.S. And so getting that broad picture of what sensor systems are capable of. And number two, at NASA's Jet Propulsion Lab, we were very much focused on earth science. That was one of our key areas of endeavor and research, and just the incredible sensors that people could make. And again, we worked on the defense side, we worked on the NASA and science side, but a lot of those capabilities are symbiotic, right? And so building a sensor to do national defense work to detect certain things, like, for example, ballistic missiles being launched, that's essentially a very sensitive IR sensor. Well, that's the same thing you need for detecting wildfires. And so as that technology has advanced and been driven forward, it can serve both functions, both a defense function, but also a science and a wildfire detection and operations function. So bringing all that together for Australia. And again, for SmartSat and now for the Australasian Space Innovation Institute, or ASII, which is our follow-on, one of our big supporters is defense, but also one of the things we worry about is the science. How do we do the research that pushes the science forward, and especially in the wildfire detection perspective? So all those things come together, and it really is a powerful way to move forward.
In your prior experience doing, as you pointed out, science and defense and intelligence, did you actually touch wildfire? I mean, was wildfire an element that you were looking at in any of those fields in your prior endeavors?
Well, interestingly, as we even developed defense IR capability with those very sensitive systems, we found serendipitously that we could see wildfires, right? So then we were actually creating pathways to get what was originally classified data for defense and intelligence. How do we get this very useful information to a user in an unclassified form that doesn't show where it came from or how it was originated, but can be useful? So there was already that going on. And then certainly at JPL, NASA has a whole wildfire program that they've been working in the last several years. And so just looking at what are the opportunities to utilize either existing sensor technology that could be applied to wildfires. And again, this is pretty much IR. You're looking at IR initially, infrared, or we're on the path to develop new sensor capability that, let's say, is looking at heat maps in a particular city. But guess what? I can also apply that to a wildfire ignition somewhere in the middle of the outback. So all those things come together.
When you think about all the capabilities that satellite technology has around wildfire detection and resilience, what do you think the shortfall is in terms of what's being used currently? When you have such a background in this, are there areas where you feel like they're really being satellites are being underutilized in this kind of role?
Yeah, I think we can do better. I mean, there's two answers to that question, in my opinion. One is, frankly, you would love to have 24/7 full coverage of Australia, right? I mean, that is the holy grail because you want to be able to look anywhere at any time with enough fidelity. In other words, I can see a very small ignition, whatever that small, define as you wish, may be, and I get an instant alert, right? That's the goal. We're simply not there today. I mean, we bring in together the geosynchronous spacecraft. They give you more of that, some of them give you the 24/7, but they're just not accurate enough and sensitive enough to give us a lot of help initially with a small fire igniting. Then you bring in the low Earth orbit satellites, which start to give you the accuracy and the detection range that you need to detect fires close to ignition, but the coverage is, frankly lousy. I mean, you got LEO satellites going over and you get 4 minutes of coverage and then it's gone. Well, I have to have another LEO satellite. And people are working on that, but it's not the easiest thing. I mean, you look at Starlink and what Elon Musk is doing to give you global coverage, but it's thousands and thousands and thousands of satellites. Now, we shouldn't need that, let's say, especially for a focused coverage of Australia, but it takes a lot of satellites to give you that type of coverage. So that's where I think the investment has to be. That's where the technology has to be. And then, looking at even when I start to have all of that, do I have the data management that allows me to bring all this together across all, space-based, airborne, ground-based detectors, whatever, and get it to the operator at the point of the spear?
Yeah, well, thanks for your candor about the shortcomings of satellite imagery in support of wildfires. It's, there, as with everything, there tends to be more hype out there than what the reality is. And, I'm a firm believer that wildfire detection it's an ecosystem. There's
Hmm.
not one technology that can cover everything. You've got applicability for ground sensors, for PTC
Hmm.
cameras, for
Hmm.
satellite,
Hmm.
and everything in between. And I think each one plays a role, and together it can all be orchestrated in a way that provides maximum detection. But, I think sometimes technologies come to market with a we can do it all perspective. And those of us who've been in this world for quite a while know that that's just not the case. So I appreciate you sharing that. There has been, just a quantum leap in terms of quality from satellites, but still not in a place where there's enough ground-based intelligence to really capture that information within, the minutes that are really necessary.
And I will say that, I mean, I do believe the technology will get to the point where we can have that 24/7 eye in space that gives us what we need. I'm actually an advisor for a startup company in the US that's utilizing some JPL and sensor technology and things like that, where that's their goal from geo, give you the sensitivity with the focal point array that you can actually detect what you need to detect very early in the ignition sequence. But when does that happen? We'll see. But you're right. I mean, it's integration of all these things. We also work with Edith Cowan University and their Ignis program, where it's really lightning detection and lightning strike, which is the start of many fires. And so that's a ground-based sensor. So how does that get integrated and all those sorts of things? And they're doing a demo of that right now.
So, given that you're based in Australia and there's been a tremendous wildfire problem there, what differences do you see between the use of satellite technology in Australia versus in North America, specifically in the U.S.?
I don't know that there's a great deal of difference. I think all the, government firefighting organizations are seeking to utilize whatever is available. I think some of it, you could say It does take investment. It does take, let's say the rural firefighter folks saying, okay, I could have this great tool, but I got to buy it. I got to pay for the data analysis, whatever it is. So I think it's somewhat haphazard both across Australia and the US in terms of who has what capability based on what data, based on what analytics, and do I have the tools out there in the field that I can use? And, frankly, one of the frustrations I think across the US and Australia is I'm not sure there's a grand coordination scheme of how we attack this problem. You talk to people that are operating in Victoria versus New South Wales, and well, my radios don't communicate. Even though I may be on the border, how am I talking to my partner over here in New South Wales when I'm in Victoria and we're both fighting the same wildfire? So I think the coordination function at the federal level needs to be better, and the investment to get these tools out to those who are actually doing the work in the various states needs to be better.
Yeah, I was going to ask you about impediments to broader adoption, but it sounds like, wildfires everywhere tend to be more of a local problem. And one municipality, county, city will have certain tools and certain communication that they have, but it may not be compatible with the next county or town over or what have you, and certainly other states. So what I hear you saying is that to the extent that, there's more of national oversight and the
Hmm.
ability to say, here's how we can best leverage satellite remote sensing and all the great things that it provides, but it needs to be a layer that's provided across the country and is easy to access and be able to leverage before, during, and after wildfire events.
Yeah, and I think that's one of the things, at ASII, we're trying to think about how do we broadly identify the gaps across the nation of Australia and understand, okay, yeah, everybody kind of has this problem, whether it's, standardized communication or this particular standardized tool or utilizing this particular piece of data. Let's understand that. Let's identify those gaps, and then let's try to build more of a federal level program that says, okay, here's where we need to invest. And NHRA is doing some of that, and so I mean, work is going on, but and so I don't want to disparage any of that, but it's just that we need to get our arms around this. I think both in the US and Australia, like what are the key things that allow us to do this effectively, efficiently, and well across any domain, whether it's county, state, whatever, and we can all operate together with extremely valuable tools that work.
So you've had the interesting perspective of having a lot of depth in both the US and in Australia, as well as other places, but specific to those two places, are there wildfire challenges that you would say are unique to Australia? I mean, outside of equipment and everything else, but more environmental and climate based things that are different and more challenging than, say, in the US.
I would say for Australia, part of it is scale. I mean, an incredibly huge nation with a reasonably small population and capacity. I mean, you have roughly, 27 million people across all of Australia. And I kind of make the analogy that's roughly 2.5 times the size of Los Angeles County, in California. So I think part of it is just such a vast territory to deal with, and frankly, a limited pool of resources. I think that's, whereas if I look at California, which, Australia partners with through an MOU, there's a lot more people, a lot more resources, a lot more capacity to go deal with things just because there's more people, more money, more equipment. And so I think, and yet the scale of what Australia deals with is incredible. So I think that's one of the biggest challenges I see between Australia versus, the US. But again, you get out into the hinterlands of Montana or something, that's a pretty big scope of, you know, potential wildfire area that you have to deal with as well. So they're similar, but Australia just has it in spades in terms of, the size.
So, given your experience leading high stakes military and aerospace operations, what stands out to you about the operational challenges that firefighters and emergency managers face during major wildfire events?
I'll kind of fall back, having had 35 years in the US Air Force, we had, just operational standards across all that we did. This huge force of over 300,000 people that were trained to the same standards, that used the same equipment, that could operate, whether it's Unit A coming from here and Unit B coming from here. When they came together, they would operate together seamlessly because it was all of that same training, same equipment, same scenarios that they trained on, et cetera. So I think going back to our other point is that we need to get to that point where it's similar training, similar equipment, similar scenarios across every state, and taking the action to bring all of that together so that as we deal with wildfires and bushfires, people can be plugged in no matter where and how, and operate seamlessly together utilizing the same equipment that they've trained on, they understand, and they all talk the same language. That's the power of the military, frankly, because we kind of can dictate all of that. And you've got to have the money to do it, right? You've got to have the money to say, okay, we're going to standardize on this radio across every state. Well, who's going to pay for that in Australia? Now, that's a big question. So those are all things that as we move forward, we have to think about.
So it occurs to me that we've been talking about NASA JPL, and some of our listeners may not know what that acronym is. Could you just share, kind of give an overview of what happens at JPL and, of course, what it stands for?
Sure. Well, JPL stands for Jet Propulsion Lab, and we have nothing to do with jet propulsion at this point in our lifetime and their lifetime. I'm no longer there. But, JPL started back in the 40s and 50s supporting the war effort. They actually developed JATO, jet assisted takeoff, back then. And that's kind of where the name came from, was they were doing jet propulsion and ultimately then rocket propulsion, but ultimately became the first organization that built a spacecraft for the U.S., Explorer 1, in response to Sputnik, and launched that in January of 1958. And so that was before NASA was even created. So if you looked at the headlines back then, JPL launches America's first satellite. And then NASA was created later that year, and JPL came under NASA as what we call a federally funded research and development center. But we're not government. JPL is not government. It's operated by Caltech because it was a Caltech lab at the time. And so Caltech operates the lab for NASA under contract to NASA. So, and since then, we have been kind of the robotic exploration arm of NASA, whether it's rovers on Mars like Curiosity and Perseverance, whether it's a helicopter on Mars, Ingenuity, that we flew there a few years ago, whether it's missions out to Saturn and Jupiter, or Earth science for this particular discussion. I mean, huge component of Earth science work that we do for NASA, whether it's looking at carbon dioxide formation and absorption, whether it's looking at the mineralogy of dust storms coming off of Africa, whether it's looking at plant health using infrared technology. So a whole host of Earth science efforts that directly can apply to the wildfire question that we have.
In other words, you got to play with all the toys before anybody else did.
Well, it was an amazing organization.
So while there, I imagine that you saw the fusion of data, modeling, advanced sensing come together. So how important, thinking about those elements, will predictive wildfire modeling become in your estimation over the next decade or so?
I think it will only grow in importance. I mean, that's one of the areas that AC is working in, is like, how do we take all of this data and do the analytics against it, right? And so everything from fuel loading in terms of brush, and number one, mapping that, detecting that. Number two, then actually predicting based on fuel loading and weather and applying all the AI tools. In fact, I advise a company here in California that is a spin out from JPL that's doing exactly that, doing video AI analysis of fuel loading, then taking in weather data and making predictions on the probability of a wildfire being ignited. So I think all these things are going to continue to grow in capability. You're going to get more sensors on orbit. You're going to get more sensor capability, both air and ground. You're going to have more AI applied to all of this data. And then it's a question of, now let's bring it together to support the operational members on the ground, actually fighting the fire and giving them the dashboards that they need to make smart and intelligent decisions to cope with, keeping these wildfires under control.
So for the listeners that are confused about all the satellite technology coming out, could you just maybe give a brief overview of low Earth and all the other satellites, just and maybe where they fit in with wildfire detection?
Sure. I mean, I'll start up high with geosynchronous. I mean, we've had Earth observing satellites. NOAA has satellites, that look at the Earth primarily for weather, but there's IR sensor capability. And as I said, that's useful, but it's not extremely useful just because the sensor capability and the distance away. But the good news is it's always staring at the same place, right? So geosynchronous gives that synoptic 24/7 view of a particular location. And I would say, as I said, the holy grail is if I can have a sensor at geosynchronous that can see to the fidelity that I need down, let's say, of a 3 by 3 meter ignition point, which we're not there yet, but sensors continue to improve. So you've got that holy grail at geosynchronous that gives you the steering capability. And then it's primarily the low Earth orbit where you've got, because you're much closer to the Earth, you get higher fidelity resolution of the Earth and your sensors. And you can start to see very fine grained ignition points, which is what you want. But again, low Earth orbit, as I said, they're over you a very short period of time, then they're gone because they're flying around at 17,000 miles an hour. There may be, you know, 300 kilometers up or 400 kilometers. They're not over you very long. So you get a quick snapshot. But if nothing's happening during that time, well, that's not helpful. Or even if there is a fire, well, I can see it right now, but now I've got to wait X amount of time for the next look. That's not very helpful. So that's why, people are proposing and implementing larger LEO constellations with the appropriate sensors to detect and help manage fires as they propagate. But again, it takes money, it takes sensors, it takes a whole host. If you want, you know, constant coverage of all of Australia, that's a lot of satellites. And, there has to be a business case that says somebody's willing to pay for that data in order for me as a company to invest in, I'll make this up, 400 satellites to give you that type of 24/7 coverage over a particular continent. So those are all factors that go into that. I just saw an article about Gilmore Space wanting to do some work in this area. And there's other companies that are already getting satellites up there. But the question is, how much coverage you're going to get? How long is it going to last? Can I truly have 24/7 or can I do less than that, but it's valuable to me and I'm willing to pay for it as a government or a commercial entity? All those questions are out there.
What about aircraft that fill in the gaps? I've seen this, whether it be balloons or light
Mhm.
aircraft that are, filling in the gaps between where the PTZ cameras are and where remote sensing can operate. And to your point, satellites have that latency issue, but some of these aircraft can stay in one spot for an
Mhm.
extended
Mhm.
period of time and therefore kind of cover the entire wildfire event. Where do you see the role for those?
I mean, I think it's a very important role. I think it really is a matter of, going back to my old days at JPL, it's all about systems engineering. What are the components of the system that we want to bring together to give us the best solution today and in the future? So today, aircraft, absolutely. You can use high altitude balloons. I mean, people are talking a lot about, even long duration drones, but again, you got to have the right sensor. Long duration, usually up pretty high. So what sensor can I put on there that gives me the synoptic coverage that I need? So, but yeah, it's a systems engineering problem and we should bring in every capability from ground to air to high altitude to satellites. And for today, this is the best solution. Let's model that. Let's sort out what the right answer is today. But let's also define the gaps that are still there in terms, the airplanes can't fly forever. They're probably not going to detect the things because that means you're just flying over stuff that's not happening, right? So the detection question is still hard. Even with if you have the cameras, if they're the right place at the right time with the right fidelity, yes, but maybe they're not. So all those things have shortcomings and positives that we need to put together from a systems engineering approach and then do the best we can with what we have, identify the gaps and go forward and make it better.
So speaking of the gaps, and I know primarily now you're working in the satellite realm, but you talked about ground sensors and PTZ cameras and so forth. With your tremendous engineering background and what you did at NASA and other places, where do you see the gap? Like, what do you think is kind of the unmet need now? You had spoken about bringing all these things together, which I completely agree with. We've got a bunch of individual dashboards and, swivel seats that certainly could benefit from integration. But beyond that, is there a gap that you see that is unmet that might be useful in reducing response time?
I go back to the detection. I mean, when I talk to people, they talk about, if I could detect a wildfire X minutes faster, that results in much less damage, much less insurance claims, much less, et cetera, et cetera, et cetera. So number one, it's the gap of detection. And we talk about how we can get better at that. And I would say employ every possible tool you can. And then I think it's the gap of the real time information to the firefighter that is to every person that needs it. I mean, theoretically, I can pick this thing up and I can see it. You know, if I'm an individual firefighter on the line, I've got the same picture as the person in the command center, whatever. How do I bring all of that together with the tools, with the data analytics, so that we are truly one integrated organism that's going after this stuff?
You've talked quite a bit about the research that you've been involved with that you're doing now. Where do you think the challenges are in terms of taking something out of research and commercializing it? I think, I've seen some government agencies have done a great job at technology transfer, even, setting up a company that wants to, be a startup and license that technology. But other things just seem to get stuck in the lab, really good ideas that just aren't out there. And of course, funding is a big issue as
Mhm.
well.
Yeah, I think the commercialization question is all about for a company, because when you talk about commercialization, it's I'm going to get it out to either start a company or an existing company is going to take it on. They have to see the ROI, right? They have to see the return on investment. They have to see the market. And this is not necessarily an easy market because, if you go out, whether US or Australia, you go out and you talk, to the folks that are doing the fighting of the fires, they don't have a lot of money. They're all about operations. So who's going to pay for that new technology capability? Is it the federal government that says, okay, we're going to step in and we're going to try to do this more generically across the entire nation? Is it a particular state? The actual folks, boots on the ground, it's hard to say I can make a case for a commercialization because they don't have a lot of money. They're out there doing the firefighting all the time, and that's what the operations dollars pay for. So I think it comes down to who's willing to invest, and the company can see a true return on investment over the next 5 to 10 years that they can count on. That's not going to change with a changing government and those kind of things. That's to me, that's the hardest problem. It's that finding the sweet spot where a company can say, there is an ROI. I see a funding stream that will support this. I'm willing to take it on because I've got to build some things that will get it out there and commercialize it and market it and all these things. And they have to be able to see that.
Yeah, I think it's the classic conundrum that communities see where they say, okay, we have a firefighting budget here and, we need to grow that, not shrink it. But yet, there are all of these new innovations like detection and so forth that might be, very helpful in terms of thinking of the overall wildfire picture. But we can't take it away from our suppression budget. It needs to come out of a different budget, so
Well, I mean,
that's
even living when I lived here in California, I mean, when they had all these wildfires, and again, I'm in California right now for some work, and where I'm sitting was about 300 yards from the canyon fire ignition. And they'll tell you, look, we sucked up all of our budget fighting these big fires. They have nothing left to invest in future capability, and that happens almost every year. So how do you get around?
I think it's the age old ounce of prevention, pound of cure problem, right?
Absolutely. Yep.
So, Larry, we've talked about a lot here today, and there may be something that you want to share that I haven't asked. So, I'll give you an opportunity. If there's something else you'd like to kind of close with here, please feel free to share.
Well, I would just say, I mean, certainly the team in Australia, the folks we've talked to, the researchers, the firefighters, the organizations, I mean, they're all on the same page. They're all dedicated to making this better. They're all, working extremely hard to make it better because we know it is a big problem and it is dangerous. And I was in Sydney when we had the big fires there a few years ago and just remember the smoke over the city, and it's just like, wow, this is scary stuff. So it's incredible people that are extremely dedicated and do the work well. We just need to figure out how we raise the bar for integration and funding to really get after this in the very best way.
Larry, thank you so much for joining me today. The insights are incredible. Hearing about your past career, sharing what JPL means, helping our listeners understand the differences in satellite technology and all the rest. It was great to have you on today. Thank you so much for joining.
Thank you, Neil. Really enjoyed it. And let's go forward and do better.
And thank you all for listening. If you enjoyed this episode, please subscribe, share it with a colleague. Join us again for another conversation at the intersection of wildfire, technology, and resilience. And until next time, thanks for listening to Neal on Fire. We'll see you again.